Yes, students, we are going to continue with the problem. So, as I've told you, to understand only the logics in the particular problem, how to apply the KVL for that particular problem. Because you can't, some problems you can't directly apply KVL. There is some procedure that you need to do wherein after that you have to apply a KVL, right? So, that is why I told you to learn in a logical manner, and I'm also going to explain you the diagram clearly well so that it will be helpful for you a lot, right? And now let's come to this particular subject. Now this particular also I'm making it to you easy. So this particular, how whatever the videos I've left till now released in YouTube till now, if you try to follow those videos without fail, then you would easily use your exam, students, because I have done all the problems that comes for our exams only. I've taken 4-point DFT. I've done all the problems with respect to 4-point DFT. So what is the matter is here, if you see one problem, you can do all the other problem. The question will same, the procedure as the question will change, the procedure is the same, right? Yes. So that is why I have done all the things. Please do watch my videos. It will be really helpful for exams. I'm helping you a lot for your exams, and I guess you make use of it in a very good manner. And now let me come to that problem. Why I tell you all this is because I wanted to make you know things first, what we are doing, because if anybody is new to this channel, they can understand what we are doing, and they'll just get back to those old videos and watch it. That is why I'm telling, right? Yes. So please do try to understand our concern, and please do follow us so that you can get more and more videos. It will be helpful for you. I'm helping you a lot in many ways, and you people have to make use of it by watching our videos. That is what is my agenda. I'm trying to promote each and everywhere. Please do students watch that, and please do subscribe to us so that we are going to, it will be a strength for us to help you more and more, right? You people are our support and strength to help you more and more. So that is why I'm asking a subscription, because only because of this, and I'm helping you more and more. If you get subscribed, I would be more stronger, and I would get more support to still help you people, right? Yes. So let me come to the problem. The problem, endpoint DFT of x of n is equal to 1 by what I can say 3 for 0 lesser than or equal to n. Just a minute, I'm so sorry. Yes. Okay. And one more thing I wanted to clearly tell you, one who has failed in this particular subject, 18 scheme students and 17 scheme students also. So 17 scheme students, one who have still this particular subject, they haven't cleared it yet, they also can watch it. They also can watch it up to how many videos I'm going to tell you for 17 scheme and 15 scheme students. For 18 scheme students, you can watch these videos without pay. It would be more helpful, right? Yes. And here it is 0, because those students also can make use of it. Now it is not that the new 2022 scheme students have to make use of it. The 118 scheme students and the further students can also refer this if they have backlogs in the particular subject, right? Yes. Okay, so this is what is the question, and now we have a formula. So directly we need to write a formula x of k, because we are asked to find out what DFT, right? DFT. So therefore it is x of k which is equal to what? X of k which is equal to what I can say, the summation of n minus 1 to n is equal to 0. N is equal to 0, that is x of n into e to the power of x of n into e to the power of minus j 2 pi minus j 2 pi, which one? That is e to the power of minus j 2 pi kn by n, or I can directly write it as what? So I can directly write this as, that is e to the power of minus j 2 pi by 2 pi kn by n as what? That is, I can write it as omega n kn, right? Yes, what is my omega n? E to the power of minus j 2 pi is my omega n. Fine? Yes. So now if I write it, so then next what I am supposed to do is, I have to, what I can say, directly take, what I have to do is start. So here I know my x of n. My x of n is 1 by 3. So right, I need to take 1 by 3 into what I can say, my omega n kn. So for omega n, here it is my, what I can say, omega n. Here it is my omega n. My n remains constant. And here it is for k and n, you are going to substitute. Here is given for 0 lesser than or equal to n lesser than or equal to 2. That means that your value will lie between 0 to 2. This condition is going to tell you the value, that is the values of n. So how much values of n you are going to make use of. That is, for here it is 0 lesser than or equal to n lesser than or equal to 2 is telling me that my value ranges from 0 to 2. Just a minute, so sorry. Wait. Yes. Okay. So it is 0 to 2. Right? Just a minute. So sorry. Okay. It is 0 to 2. My value ranges from 0 to 2. That is, value of n ranges from 0 to 2. So what I have to do? I need to keep this omega n as it is. So then I have to substitute what? I have to substitute what I can say, that is, here k is equal to 0 to n minus 1. Here my k is equal to, just a minute, I am so sorry. Here my k is equal to 0 to n minus 1. Right? Yes, my k is equal to 0 to n minus 1, and then next thing you are supposed to substitute. First your k is equal to 0 and n is equal to 0. So I get it as omega n to the power of 0. Why? Because what starting value of n is 0 and this k is 0. So what happens? You are going to get it as omega n to the power of 0 itself. Right? And here it is 1 by 3, that is omega n to the power of, what I can say here, this one. Which one? That is omega n to the power of, what I can say here. So that is what I can say here. This one. Which one? That is k. Right? Here what you are supposed to do is, here you need not to substitute the values of k. We are telling that our k is equal to 0 to n minus 1. Sorry for the distraction. Here we are telling that our k ranges from 0 to, what I can say, the n minus 1, but we are not substituting the values of k, as here is only told you to substitute the values of n. So therefore we are going to substitute the values of n. Here is giving the range only of n. He is not telling you the range of k. So don't try to substitute the value of k. Keep the value of k as it is. Say that your k ranges from 0 to n minus 1. Sorry, as is given the values of n, the range of n, you have to only substitute for the values of n. So then you get it as 1 by 3 into, what I can say, the omega n of 2k, right? Okay, omega n of 2k, and wherein here what happens? Here omega, that is 1 by 3 is common, so you get it as omega n to the power of 0 plus omega n to the power of 1, or omega n to the power of k, plus omega n to the power of 2k, right? Yes. So for your k, what? For your k is equal to 0 to n minus 1, right? Yes, that is what I have written it like this. Just you have to write it over here as well as over here, right? Yes. So this is what is my problem. So what is my problem is that, so I have 1 by 3 for 0 lesser than or equal to n lesser than or equal to 2. So what is that telling? 0 lesser than or equal to n lesser than or equal to 2. It is telling that my, what I can say, the n range is from 0 to 2. That is, from 0 to 2 you are going to substitute the values. That is 0, 1, 2 is the values that you are going to substitute for n. And here you know what is x of k formula. That is, you can write it as n is equal to 0 to n minus 1 this one, n is equal to 0 to n minus 1, that is x of n into e to the power of minus j 2 pi kn by n, or I can write it as omega n kn, right? Yes. So now e to the power of minus j 2 pi is omega n, right? Yes. And now here my k ranges from 0 to n minus 1. And what is that going to happen is that, so you have to substitute the values of n and leave k as constant, because k you need not to substitute, this capital N you need not to substitute, a small n is the value that you need to substitute. If you substitute that, so you're going to get it as what? You're going to get it as this. That is, here you have substituted your small n is equal to 0, wherein k into 0 is 0. Here you have substituted your small n is equal to 1, wherein what I can say, yeah, this one, that is your what I can say, k remains the same because it is 1 into k, which is k. Here I substituted a small n is equal to 2, wherein 2 into k is 2k, and here this is 1 by 3 because my x of n is equal to, very first value is 1 by 3, this is 0. So 0 is not at all considered. Fine. Yes. And this is what is my resultant, right? So now let us move on to the another problem. Just a minute, students. Yes. Okay. Just a minute, students. Wait for a second. Okay. I'm going to write the question now. So this one, that is your x of n is equal to, okay, which is equal to cos 2 pi This is what is my question, students. Okay. So here in this particular question, it is being given that what I can say, your cos 2 pi, that is k naught by n for 0, that is for 0, what I can say, this one, that is 0, what I can say, lesser than or equal to k, lesser than or equal to n minus 1. So what I can say that for your cos, what I can say, for your cos, that is 2 pi k naught n. So for your cos 2 pi k naught n divided by n, so for that there is one rule. So that is, there is one formula for that, that is cos 2 pi, that is k naught by n, which is equal to what? Just a minute. I'm so sorry. Okay, so this is, for this you have a certain formula which says that cos 2 pi k naught n by n, which is equal to 1 by 2 into e to the power of, that is what I can say, minus j, just a minute, minus j 2 pi k naught n plus 1 by 2, just a minute, yes, it is plus j, and plus 1 by 2 into e to the power of minus j 2 pi k naught n by n. So this is what is the formula for, this is Euler's rule, wherein Euler has suggested a rule for cos this particular for cos this formula, wherein your formula will be equal to 1 by 2 e to the power of plus j 2 pi k naught n by n plus 1 by 2 into e to the power of minus j 2 pi k naught n by m. Right? Yes. Now, what I am supposed to do? I know that my e to the power of, that is minus, j, which one, that is e to the power of, what I can say, that is minus j 2 pi k by n, which is equal to omega of n. Yes, I know that, right? I told you in the last session. Now it is e to the power of minus j 2 pi by n. I'm sorry if I got to tell n in that particular. So it is e to the power of minus j 2 pi by n is equal to what? That is my omega of n. So if I substitute my omega of n over here, here I get it as what? I get it as half into what I can say, that is here omega n into, very first is minus k naught of n, because so here it was plus j. So for plus j, my k naught will become equal to minus k naught. For minus j, it is plus k naught only. Fine. Because it is e to the power of minus j 2 pi by n, it is e to the power of minus j 2 pi by n is equal to omega of n. But here it is e to the power of plus j 2 pi by n. So that is why what I have to do is that, so I have to take minus k naught for that. Fine. Yes. And here it is half of, that is omega of n into kn. Fine. Yes. So now this is what is my one step. So now what I am supposed to do is that, so I know my x of k formula. See, here we did not directly apply the x of k formula. See, we just had a formula, Euler's formula, for what I can say, the cos 2 pi k naught n by n, wherein we substituted that, we got this resultant. Then here also we got to know that t to the power of minus j 2 pi by n is equal to omega of n, and that omega of n here we substituted that here, wherein in this particular part it was e to the power of j 2 pi by n, it is plus j 2 pi by n. So for that we need to take minus k naught over here, and here it is 1 by 2 omega of n, that is k naught n, right? Yes, that is k naught n. Okay, and we got this now. So now we are supposed to apply what I can say, this one, that is your DFT, right? Here you need not to directly apply DFT. Please to see the question. If there is any simplification to be done, try to simplify, and after the simplification only try to apply DFT, right? Here we are doing the same thing. So now if I consider the DFT, x of k, which is equal to what? It is equal to summation of n minus 1 to n is equal to 0. That is what I can say, my, just a minute students. It is my x of n into, wait a minute, x of n into e to the power of what? E to the power of, that is minus j 2 pi by minus j 2 pi by n into kn, or I can write it as, that is, here this one I can write it as here omega n kn, right? Yes. Please don't directly write omega n kn, because many of people who's new to this formula, they think how omega n kn come into existence. That is why you need to know this one, that is e to the power of minus j 2 pi by n is omega n, you need to understand, right? Yes, and now here what I'm supposed to do is, my x of n is what? My x of n is what? That is cos 2 pi k naught n by n. So let me substitute that. So I need to write another step substituting that. Don't directly write that. Okay. First write the formula, then try to write that without fail. Fine. Yes, this is cos 2 pi. What I can say, the k naught n by n into what I can say, that is your omega n kn. Fine. Now we know what is cos 2 pi k naught n by n. We have already found out, right? Just a minute. I'm so sorry. Okay. And once again, so we have to now substitute the value of cos 2 pi k naught n by n. So if I substitute that, I would be getting it as what? I would be getting it as, that is what I can say, my half into, I need to what I can say, take the summation, that is n minus 1 to what I can say, the n is equal to 0, because we have still not simplified, right? So we are still not simplified. We are just only substituting the values of what? We are just substituting the values of cos 2 pi, what I can say, k naught n by n. That is why I still need to take this. So that is why let me take n minus 1 to n is equal to 0. So it is equal to 1 by 2 into what I can say, the which one. So I need to put a bracket. So 1 by 2 into omega n into k naught of n minus k naught of n. Just a minute. Yes. So it is plus 1 by 2 into omega n into k naught of n into which one? Into your omega n k n. Right? Now what I do is that I have 1 by 2 as common, right? I have 1 by 2 as common, so I'll remove 1 by 2 outside. So if I remove 1 by 2 outside, I would be getting like this. So that is, I would be getting it as, that is 1 by 2 into what? 1 by 2 into, that is summation of what I can say, n minus 1 to n is equal to 0. What I can say, I need to put a bracket still, that is stating here omega n into minus k naught of n plus, that is equal to omega n k naught n into omega n k n, right? Yes. Okay, yes. So now what I'm supposed to do is that, so now what I'm supposed to do is that, so now I have to, what I can say, multiply this omega n k n to this particular, that is omega n k naught n and plus omega n k naught n, right? Yes, so that is, I would be doing that. So I would be taking like this. So that is 1 by 2 into n minus 1 to n is equal to 0. Why I am doing these steps is because you have to understand, in textbook he'll give you directly. First, what did I do? I just took this 1 by 2 and I just removed outside because it was common. Now I have to multiply this omega and kn to this particular as well as this particular, right? Yes, there are few more steps that will lead to that particular step, direct step, but you have to, what I can say, please to work out, right? Yes, or else you don't even know how did you get it, right? Yes, plus, no, still it is not multiplied, a minute. Yes, so it is omega n into kn plus what I can say, omega n into k naught n. Yes, right? So now what I have to do is, the next step is I have to remove common. So here, yeah, so here my n is common, but this k and k naught is varying. So what I'm supposed to do is I have to take common. So how do I have to take my common as that? So it is n minus 1 to n is equal to 0, which is equal to what I can say, the omega n. My omega n is the same, but here k and k naught is varying, this n is the same. That is why I take k minus k naught by n, right? I take what? I take, that is k minus k naught into n plus into n, I'm sorry, into n, and it is omega n into k plus k naught by n, because there is k naught is positive, here k naught is negative. Right, it is k plus k naught into what I can say, minute students, yes. It is k plus k naught into n. This is what I am going to get. Now what I am supposed to do is I have to multiply this 1 by 2 into summation of n minus 1 to n is equal to 0 for this particular as well as this particular. If I multiply to both, so what I would be getting at as, right? I would be getting at as, just a minute, I'll write it over here itself. Minute students, yes. Okay, so now if I multiply that, I would be getting it as 1 by 2 into, that is summation of what? That is summation of n minus 1 to n is equal to 0. Among students, yes. Okay. That is n minus 1 to n is equal to 0. What I can say here, omega n into which one? That is k minus k naught into n. That is what I can say, plus that is omega n into but that is plus what I can say here, 1 by 2 into to multiply for that also, right? Yes. So that is why it is equal to 1 by 2 into 1 by 2 into n minus 1 to n is equal to 0. That is omega n into what I can say, that is your k plus k naught by n, right? Yes. Yes. So this is what you are going to get. This is what is your direct step. For this direct step, you have to do these many things. What you have to do? So here you know this, right? This one you got. After this particular step, let me consider this as step number 1. After this particular step, so what he'll do is he'll just directly come to this particular step, right? This particular step, which is step number 2. So if you don't understand, how do you get, then how do you understand, right? That's after that step number 1. If he comes directly to step number 2, you don't understand things. The one who's over brilliant or super brilliant can understand, but the one who's in the lower one or the middle one, they don't understand much. So that is why you need to understand all these things. So after the step called, you're going to do all these steps. What you have to do, you have to remove 1 by 2 as a constant, and then what you have to do is you have to, after removing 1 by 2 as a constant, you are going to get this. After that, you are going to multiply omega n kn to this both, wherein when you multiply, you are going to get it like this. And after that, you see that omega n is constant, and this this n is also the same, but minus k naught and k varies. That is, this is a to the power of n in m into b to the power of m is equal to n is equal to a to the power of m plus n. That exponents, that is properties of exponents you have, no? So there you get it. Just a minute students, I am going to tell that. Okay. Yes. So you know that a to the power of m into a to the power of n is equal to a to the power of m plus n. Whatever I told you now, that is what is same thing, right? That one you are going to apply it over here because it's in the form of a to the power of m into a to the power of n. Here what is that going to happen for m plus n? Your k and k naught varies and your n is the same. So therefore instead of writing omega n to the power of kn minus what I can say, minus that is k naught of k naught into n, instead of writing like omega n to the power of kn minus k naught n, just a minute, I am just writing a rough figure, k naught n, so we can write it like this, that is k minus k naught whole into n, right? Here also instead of writing omega n to the power of kn plus k naught n, I can write it like this. So that is what you are supposed to do. And then what are supposed to do next is that you're going to, what are you going to do next? You're going to, what I can say, multiply this 1 by 2 into summation of n is equal to 0 to n minus 1 to here, right? To this particular as well as this particular. So if I multiply the summation to this one as well as this one, so what are you going to get? You're going to get it like this. So this is what is my resultant. I multiplied this summation to this particular, that's k minus k naught into n, and this is 1 by 2 into n, this 1 by 2 into summation of n is equal to 0 to n minus 1 to this summation, to this one, right? I multiplied it. So this is what is my step number 2, and to get the step you are supposed to what? You are supposed to do more and more efforts, right? That is why I am telling you, please do don't directly write the steps. So in the sense, in the textbook he'll give you directly, try to solve more and more steps, so to understand things better. So to understand things better, you're going to do more and more steps. Don't see the direct step blindly and try to practice that. You have to know how that direct step come into existence. After step 1, if you directly write step 2, you don't know how did you get the step 2. So that is why try to understand how the step 2 come into existence. Fine? Yes. Now, what's that going to happen is that, so just a minute students, next thing, what is that going to happen? What is that going to happen in the next is that, so now here you can, what you're supposed to do over here is, so now I'll just push it up. So if your k is equal to k naught here, right? If your k is equal to k naught in this particular one, let me consider that your k is equal to k naught. What is that going to happen? What is that going to happen is that, so you are going to get a summation of n minus 1 to n is equal to 0. Try to understand things in a better manner. I am explaining it to you clearly. I have showcased you each and every steps over here. This question will come for exam. The same for a sign. But for a sign, I guess the formula might change. Euler's rule formula might change. Please do look at that. But all this process will remain the same for sign. Fine. You will also get a question on sin 2 pi k naught n by m. Right? I am repeatedly telling you. Fine? Yes. And here my omega n, just a minute. So my omega n, that is equal to omega n to the power of k naught minus k naught. Right? My summation of, just a minute, I'll just briefly write it. Yes, just a minute. Okay, so I get it as omega n to the power of k minus k naught, k minus k naught whole to the power of n. So which is equal to what? You are substituting in place of this particular k, you are substituting k naught. So I would be getting it as, that is n minus 1 to n is equal to 0. So that is omega of n into k naught minus k naught just a minute, I am so sorry. Okay, so you get this resultant. So wherein so you get this resultant wherein your k naught minus k naught will become equal to 0, and I would be getting it as, that is what, my summation of n minus 1 to n is equal to 0, that is your 1 to the power of n. Why 1 to the power of n? Because you would get it as omega n to the power of 0 here, right? Or I'll write that step also for your understanding. So because if you learn each and every single things also, you'll understand, right? For many of the students who find problematic subject complex, if they see these direct steps, they don't even understand. They would be like, how did this step come, what I have to do? So for those kinds of people, try to simplify each and every small parts and try to understand, so that then you can write however you want in your exam. You can write the steps directly, or you can write all the steps which you require, that is all the simplified step also. It is your wish, but for your understanding, make sure that you just simplify each and everything in a clear manner, so that you understand, right? Yes. So it as, I get it as omega n to the power of 0 into n, right? Omega n to the power of 0. So this 0 is in brackets, omega into the power of 0 into n. So wherein I am going to get it as what? I am going to get it as that as 1 to the power of n. So why 1 to the power of n? I am telling you once again, this is what is the result. So here many people will think, so this k0 minus k0 will be 0 for me, and I will get as a 0 into n. So my 0 into n is whole total is 0. Anta, you will think, no, you should not multiply this 0 with n. That is what you people have to understand. So when you see this k0 minus k0 is equal to 0, you people think that I will be getting it as here 0, this into n. So the 0 into n will become equal to 0, and my omega n to the power of 0 will become equal to 1. No, this is omega n to the power of 0 is separate. This omega n to the power of 0 is separate, and here n is separate. So it will become 1 into n. Right? You need not to multiply this 0 into n. This n will be as it is. You need not to do anything with respect to n. You are going to, what I can say, take only omega n to the power of 0, which will give you 1, and that 1 is over here. Right? Don't try to multiply 0 into n. No, you should not do that. This 0 is for only omega n. This 0 is only for omega n. It is not for n. Your n will remain the constant, and this omega n to the power of 0 will become equal to 0, become equal to 1, and that 1 to the power of n you will get. Okay, don't do that mistake or else you will fail. Fine, that is what I am telling you, right? Yes. Okay, for k, what I can say here, for k is equal to k naught. Okay, for k is equal to k naught, right? So now what I'm supposed to do is that, so after this, so now I need to take this second equation, this second one, and I'm telling that here my k is equal to minus k naught, right? My k is equal to minus k naught is why? Because I need to get 1 to the power of n, that is why minus k naught plus k naught will become equal to 0. So if I take it as, my k is equal to minus k naught, keep this one is very important, keep this one. Okay, I'll tell you about this again. So if my k is equal to minus k naught, just a minute. Then what I can say is summation of n minus 1 to what it is here, what I can say, omega n to the power of this, what I can say here, k plus k naught will become equal to, I'm going to write it clear manner so that I guess you'll understand things better, right? Do this, do all this, it is for a benefit, right? If you do simplify, it is all for a benefit, right? Please do try to understand that. Fine. Yes, and this is k plus k naught. So which is equal to, what I can say, the summation of, that is your n minus 1 to n is equal to 0. Okay, that is your omega n to the power of, this is n, I forgot, I'm really sorry. So you get it as minus k naught plus k naught, right? I'll write it this time, a student. Okay, into n. So which I get it as what? I get it as my summation of n minus, n is equal to 0 to n minus 1. You should not tell n minus 1 to n is equal to 0. You should tell n is equal to 0 to n minus 1. Fine? Yes. Okay. So it is my omega of n into which one? It is my omega of n into, just a minute students. I'm so sorry. Wait a second. Okay. Omega of n into what I can say, my 0 into n. So you need not to, what I can say, multiply 0 to n. I've already told you, which is resulting in what? So which is resulting in, a minute students, I'm so sorry. Yes. So which is resulting in what I can say, that is your 1 to the power of n. Once again the result is the same. Fine. It is n is equal to 0 to, okay, n is equal to 0 to n minus 1. So which is equal to what? Here 1 to the power of n for k is equal to minus k naught, right? Just a minute. Okay, for k is equal to minus k naught, and then what is supposed to do is that, so the next thing what is supposed to do, this one you can write it as, that is n is equal to delta of, just a minute, I'm so sorry. Yes, just a minute. Okay, this is what you can write it over here, and for this particular you can write it as, that is n into, so delta of k plus k naught. Why I am writing it is because, so if you, what I can say, what is that, is that you know about your unit impulse function. Your unit impulse function states that for the value of 0 it is 1. What? Like this, right? Yeah. For the, what I can say, the amplitude 0, for the time period 0, amplitude is 1. This is what is my delta of n, which is my unit impulse function, right? So now if I substitute here my k is equal to k naught, what I get? I get k naught minus k naught, which is equal to 0, wherein I get it as delta of 0, which is equal to 1, right? Yes. Here also if I substitute minus k naught, then what is it going to happen is minus k naught plus k naught, which is equal to 0, wherein I get it as a delta of 0, which is equal to 1 once again. So that is why I am writing in terms of this. That's why I am taking an impulse function. Fine. Yes. So now I need to write my resultant as, so let me write my total resultant. So my total resultant will be is equal to, what is my total resultant will be is equal to 0 for k is not equal to k naught. Why? Because we are considering here k is equal to k naught here, right? So for k is not equal to k naught, for all other things is 0, right? Yes. This is a very simple one that we are trying to use. Please do use it. Many people have used alpha to the power of n formula. That's really complicated. Fine. There is another method also, but please do try to do this without wait. Just a minute. I'm so sorry. Okay. And now you have to write, that is your n by 2 into which one? So that is your n by 2 into delta of k minus k naught. Just a minute. I'm going to tell you about this. I'll write it first. Fine. I guess you got this, because we are using k is equal to k naught and k is equal to minus k naught. For k which is not equal to k naught, your values are 0, right? Yes, just a minute. I'll write that clearly. Okay. So now, how did you get this? I'm going to tell you. Wait a minute. I'll write it first and I'll tell you. Okay. Okay. And it is plus n by 2 into. Okay. For otherwise. Fine. It is otherwise. So otherwise in the sense that k is equal to k naught and k is not k is equal to minus k naught. Right? Yes. So it is just a minute. I'll write it as otherwise. Okay, so now how did I get this is that, so now I got to this particular, how I got it is that this n by 2, that particular, the 0 I already told you, right? How did I get is that, so we've got an equation number 2, right? By this equation number 2, I have written equation number 2 somewhere, I get it got erased. Wait a minute. Yeah. So I got this equation number 2, and after getting this equation number 2, what did I do is that I simplified this omega n into k minus k naught, omega n to the power of k minus k naught into n. What did I do? I took k is equal to k naught here, and here I took k is equal to minus k naught and I simplify. If I simplify this particular, for this particular one, I got my resultant as what? That is n delta of k minus k naught for this particular, which one I simplified for, that is what I simplified for, that is my summation of n is equal to 0 to n minus 1 omega n into k to omega n to the power of k minus k naught into n, and I simplified for n is equal to 0 to n minus 1, that is omega n to the power of k plus k naught into n. If I simplified that, so what is that I got the resultant is this, that is n delta of k minus k naught. For here I got it as n delta of k plus k naught. Just a minute. Okay. So now what is supposed to do is the next step over here is that, so you have to take 1 by 2 into n gamma of k minus k naught plus 1 by 2 into n gamma of what? That is n, I'm sorry, n delta. Sorry, really sorry, n delta of k plus k naught. So which I can write it as that is equal to this one. So I substituted this particular, which I got the resultant as n delta of k minus k naught, and this particular I substituted wherein I got it as n delta of k plus k naught, right? Yes. And here, let me erase this. This might be as an distraction. Yes. And after that I just substituted and I just multiplied with 1 by 2 over here, wherein I got my resultant as this. That is what I can say, my 1 by 2 into n delta of k minus k naught is equal to n by 2 delta of k minus k naught. Here it is n by 2 delta of k plus k naught, because this n gets multiplied to 1 over here, wherein I get as n by 2 into delta of k minus k naught, n by 2 into delta of k plus k naught. That is what I wrote it here. That is n by 2 into delta of k minus k naught plus n by 2 into delta of k plus k naught for otherwise. That is for otherwise in the sense it is for k is equal to k naught, for k is equal to minus k naught, for all other values, right? Yes. And this is what is that particular question. Okay. For cos 2 pi k naught Now cos 2 pi k naught n by capital N. For that it is like you have a question based on sign also. The same question, but in place of cos you're going to get it as sine, and for that particular sign, so what is that going to happen is that, so you have to for that particular sign, what is that going to happen is that, so your Euler's rule will get changed, but your result will be the same. Somewhat the process will be the same, but your Euler's rule will change. Euler's rule in the sense over here, so it is going to what I can say here. So here it might become your minus, here it might become your subtraction. So that might change, but everything will be the same. So see here for this cos 2 pi k naught n by n, so we need not to directly substitute to the formula. So we have to make a simplification based on Euler's rule, wherein we did this based on Euler's rule simplification, and then what I can say, after we simplified with respect to Euler's rule, so then what we got to know, that we got to know e to the power of minus j 2 pi by n as omega of n. So wherein we substituted that omega of n, wherein what happened is that in this particular, what I can say, the this one, it was e to the power of j 2 pi by n. So therefore I had to write it, instead of plus k naught I have to write it minus k naught. Here it is plus k naught only, but as part of it is e to the power of plus j 2 pi by n, and here it is e to the power of minus j 2 pi by n is equal to omega n. So that is why I need to take, instead of k naught, I need to take it as minus k naught, because it's e to the power of plus j 2 pi by n into kn, that is why, right? And this one, and here also for e to the power of minus j 2 pi by n, we substituted omega n, omega n into k, omega to the power of k naught n. Right now I try to substitute this in the particular formula. This formula you know already. And if I substitute in this formula, first I have to write cos 2 pi k naught n by n into omega n to the power of kn. After that you are going to substitute what is this cos 2 pi k naught n by n. I substituted this over here, and what I did is I took 1 by 2 outside, so wherein I got this resulted, and after that I multiplied omega n kn to this both, wherein when I multiplied to this both I got like this, wherein this resulted in, that is your a to the power of m into b to the power of n, which is equal to this 2 and this 2, resulted in what, that is a to the power of m into b to the power of n is equal to a to the power of, just a minute, which resulted in a to the power of m plus n, right, which resulted in a to the power of m plus n, a to the power of m plus n. So if you use that, so you would be getting like this. So this is a to the power of, this is m and this is n and into n, right? This is m, this is n into n. So it is like a to the power of m plus n only, but what is that going to happen is, here it is k and here it is minus k naught, and here n is the same. So that is why we took k minus k naught into n, and here it is k and k naught is different, but n is the same. So here we took omega n into the power of k plus k naught into n. And then now what we have to do is that we have to once again multiply 1 by 2 into this summation to what I can say, this one, that is omega n to the power of k minus k naught into n, and omega n to the power of k plus k naught into n. If you multiply, you are going to get it like this. And what is that going to happen is that, so then what is that going to happen is that, after that we are going to simplify the summation of n is equal to 0 to n minus 1 omega n to the power of k minus k naught into n, and summation of n is equal to 0 to n minus 1 omega n into to the power of k plus k naught into n. So here I am showing my this one, that is an arrow mark, that arrow mark in black. So please do follow that. Okay, yes. And now if I simplify that, what I am supposed to do, I am to take k is equal to k naught. If I take k is equal to k naught, then what's that going to happen for this particular is that, so k naught minus k naught, which is equal to 0, omega n to the power of 0, you will get like this, wherein after that you are going to get this resultant. So here k naught minus k naught will become equal to 0, and you get omega n to the power of 0 into n, wherein you need not to multiply this 0 and n, it is only for omega n. So this omega n to the power of 0 only you have to only consider. Don't multiply this 0 into n. Try to multiply, try to simplify only omega n to the power of 0. Keep your n as it is, so omega n to the power of 0 become equal to 1 and this n will be at the power place itself. Fine. And then what is that is supposed to do is that, so for this particular one you are going to substitute k is equal to, just a minute students, I am so sorry. Yes. So here you are going to substitute k is equal to minus k naught, wherein what is supposed to do is that you are going to substitute k is equal to minus k naught. So here we substituted k is equal to minus k naught, wherein it is minus k naught plus k naught which is equal to 0. This one you are going to get, wherein you are going to get 1 to the power of n. It is for k is equal to minus k naught also you get 1 to the power of n. For k is equal to k naught also you get 1 to the power of n. So this one you can write it as, this one you can write it as what, your n into gamma of k minus k naught. Why? I'm sorry, delta. Really sorry for the distraction. It is delta of k minus k naught. So why delta of k minus k naught? Why delta of k minus k naught is because, so what's that going to happen over here is that my delta of n, my delta of n is what is my unit impulse function, wherein for unit impulse function it is here what I can say, the amplitude is 1 for time period 0. For 0 the amplitude is 1. So that is why if I substitute here k naught, so k naught minus k naught become equal to 0, wherein gamma of 0 will become equal to 1. Here also if you substitute what I can say, the this one minus k naught, so you have to substitute k naught. Here you have to substitute minus k naught. If you substitute minus k naught, it is minus k naught plus k naught which is equal to 0. So your what I can say, delta of 0 which is equal to 1. This is delta of 0. I'm really sorry if I have told it as gamma. It is delta of 0. So delta of 0 becomes equal to 1. Here also delta of 0 becomes equal to 1. Right? That is why we are going to write it like this. Fine. And now here what I am supposed to do is that I have simplified those two summations and I am going to write the resultant of the summations over here. Now if I write the resultant of summations over here, what I am going to get is I am going to keep 1 by 2 as it is, and this summation resultant is n gamma into k minus k naught, and this 1 by 2 I am keeping it as it is, and this summation resultant is n gamma of k plus k naught. So wherein if I multiply this once again, I would be getting the resultant as n by 2 into gamma of k minus k naught plus n by 2 into gamma of k plus k naught. And now here if I write it in terms of this procedure, so I'll be getting it as 0 for k is not equal to k naught. So for k is not equal to k naught, in the sense if you are using I'm so sorry, if you are using any other any values other than k naught, then it would be like k is equal to it would be like 0, and here for otherwise it is this particular resultant, right? And this is what is for today's lecture, and please do like, share and subscribe, and please do avail of facilities in a good manner. Don't spend your money on any other ways. Try to get this avail all these facilities for free, so that it would be really helpful for you. It is usage of money, as well as you will understand things better. So understanding things better is the main agenda. It is not with respect to your money, right? Wherever you go, wherever you give money to learn this, it is fine, but your understanding should be really important. So try to follow my channel so that you will understand things in a better manner. I am going according to your examination point of view itself, and I am helping you to ease your subject in a clear manner. I am going to make you, very first thing I am going to make you know that what is your examination question paper, how the question comes for exam, what you have to study for the exams without fail. Because if you don't know the question paper and try to blindly solve any subject, then it would be really difficult, because at the end you're going to write your exams only. For your exams you need to know how the question comes. That is why try to first see the question paper, try to analyze the question and start working on that. Don't try to study things blindly. It is really a waste. And this is what I was about to tell you, and thank you.